Hi, and welcome to Haze 3D. For those of you new here, my name is Jason. In today's video, I will be 3D scanning this metal fixture. What is it for? I have no idea, but I found it lying around. And what I hope to accomplish with this is, again, 3D scanning it and reverse engineering it in EX Model, which is a software by Shining 3D. Now, the scanner that I have here is the Scan C by, once again, Shining 3D, not sponsored. It gives great results. Now this particular scanner is discontinued, so take that for what it is. It's a pretty decent scanner. I think it has like 35 microns of accuracy, and between 35 and 50 microns of accuracy depending on your working distance. So with that all said, let's begin. Okay, as you can see, the part is already being scanned. Couple of things to note. When you're scanning an object such as this, it has really flat surfaces, really flat features. It's a good idea to have as many markers as possible, either on the turntable, as you can see, or the object itself. This would help with not only accuracy, but with alignment, should you need it. As you can see, it's being scanned, and every 15 rotations it will stop, allowing you to then select any unwanted data and then deleting it. And then you will repeat the process. As you can see, I don't have the backside, so I am changing the orientation of the object so that I can fill in that spot there. And typically when you're 3D scanning, you want to try to get as much data as possible in one go. Yeah, it's best to just keep moving the object, and as long as you're not moving the turntable itself, you should be fine. Here I am again, just looking at it closely, making sure there's no points out floating. You want to delete those. And sometimes if you don't capture any data, it's probably because it's either too bright or too dim. With an object like this, it's best to increase the brightness to help you capture more data. Once again, erasing all the unwanted points that I don't need. Taking my time. Usually this entire process probably takes like a half hour to an hour. It really depends on the size of the object and how deep you want to go with it. As you can see, here's the final mesh ready for export. It will be exported as an STL into the EX Model software, which will then reverse engineer it and create a solid step file. Okay, I'm opening up the STL. As you can see, and right now the model does not align with the coordinate system, so first thing we have to do is extract the features. To do that, we're going to select this plane here, or rather select the face, then add a plane. Now we're going to add another plane by selecting this geometry or this face here, and create to stay. Select the bottom part, add a plane. So that's looking good. Hit create. Now it's time to align it to the coordinate system. So we click this button up here, click align, and first we're going to select our main feature, which is going to be this bottom plane here. And then next we're going to select this up here. And then what else? One more plane. Select this one here. And I think I'm going to flip the Z-axis. Not that one, this one. So Z is always pointing up, and then I'm going to hit apply. Hit close. And then I'm going to hide all the planes. And then when you select your views, left, right, front, back, and top, everything lines up orthographically. That's what you want. Makes it nice and simple. Now, this isn't going to be a full-blown tutorial of how to use this program. Right now, as you can see, I'm going to kind of show you how to, I'm just rebuilding the geometry. And basically all I did was create a 2D sketch, and you kind of get a cross section, and then you can extract features from that cross section. I wish I could have shown it better here, but basically you get those points. You remember, you create a point cloud from the STL, and then you can say extract this line, extract this circle, etc. So right now, as you can see, I'm just basically building the geometry and removing a lot of it. That main part was probably the simplest, right? Because you can just do a cross section, cut right through the half of that, and then extrude both sides out so that you have this big block of metal, or in this case geometry, I guess. I apologize if I'm explaining this poorly. I will try to do a step-by-step in another tutorial, or rather another video. But yeah, as you can see, I'm kind of comparing the STL to the solid body. Now maybe you're wondering, why do you do this? So typically when we scan data, is not very optimized for CAD programs such as SolidWorks or Fusion 360. I mean, it kind of could work, but you have to decimate it, and if you decimate it, then you may lose a lot of detail, resolution, you lose a lot of information altogether. So it's best to reverse engineer it and create a solid body in a program such as this, so that you can have a clean step file to work from in your other programs. So right now I am, so once again, taking a 2D sketch. What am I doing here? So yeah, this is what I'm talking about. So you see those lines there, those are points. And then you can extract features, whatever you want. Well, here's the final mesh. As you can see, the geometry can still use some work, some more tweaks. Now I did omit some features because I'm not entirely sure what their purpose was. But again, this is for demonstration purposes only. But yeah, here you have the final step file. So there you have it, guys. I hope you enjoyed the video. I may do a few more of these in the near future. Hopefully you guys can get more familiar with EX Model as well as Quick Surface, because I believe they're the same program, just under a different name. So yeah, that's about it. Thank you for watching, and if you could like and subscribe to the video, and I'll see you next time. Peace.